Hello, this will be a demonstration of Proposition 21 from Book 5 of Euclid's Elements, which says that if there be three magnitudes and another three magnitudes, which taken two and two together are in the same ratio or are proportional, and if this proportion be perturbed, if the first be greater than the third, the fourth shall be greater than the sixth. If the first be equal to the third, then the fourth shall be equal to the sixth. And if the first be less than the third, then the fourth shall be less than the sixth. What we're given is three magnitudes A, B, C, and another three magnitudes D, E, F, such that A is to B just as E is to F, and B is to C just as D is to E. So unlike the last proposition where the proportion was unperturbed, let's say, you had the E in the middle of these two, right? So the E's would be, they'd be in the middle. But in this time, when the proportion is perturbed, they're on the extremities of the proportion. So instead of E being in the middle, we have E beginning and E at the end. But nonetheless, if A be greater than C, then D shall be greater than F. If A equal to C, then D equal to F. And if A less than C, then D less than F. We're going to deal with the first case where A is greater than C. Now, if A is greater than C, then by Proposition 5.8, which says that of unequal magnitudes, the greater has to the same the greater ratio, we can say that A has to be a greater ratio than C has to be. But A is to B just as E is to F, and also B is to C just as D is to E, which means if we invert that proportion by the Porism of 5.7, we can say that C is to B just as E is to D. We can therefore say, by Proposition 5.13, that E has to F a greater ratio than E has to D. Now, E having to F a greater ratio than E has to D, we know by Proposition 5.10 that of magnitudes which have a ratio to the same, that to which the same has the greater ratio is less. And so E having to F a greater ratio than E has to D, F has to be less than D, and F being less than D, D of course has to be greater than F. And this is what we wanted to prove. Given that A is greater than C, we set out to prove that D is greater than F, and we have proven that. Now, if A be equal to C, we know by Proposition 5.7 that equal magnitudes have to the same ratio. We can say that A is to B just as C is to B. But again, A is to B just as E is to F. And again, invertendo, C is to B just as E is to D. Now by Proposition 5.11, that ratios which are the same with the same ratio are the same with one another. We can say that E is to F just as E is to D. But E being to F just as E is to D, we know by Proposition 5.9 that the magnitudes to which the same has the same ratio are equal. We can then say that because E is to F just as E is to D, D has to be equal to F. And this is what we set out to prove. Given that A is equal to C, we set out to prove that D is equal to F, and we have found that it in fact is. Now finally, if A be less than C, we know by Proposition 5.10 again that A has to be a lesser ratio than C has to be. Again, because C is greater than A. Of course, if A is less than C, then C is greater than A. Then we can say, oh, that should actually be 5.8. My bad. By 5.8 of unequal magnitudes, the greater has to the same the greater ratio. We know that C must have to be a greater ratio than A has to be, which of course means that A has to be a lesser ratio than C has to be. But again, we know that A is to B just as E is to F. We were given that. And invertendo, C is to B just as E is to D. We can then say by Proposition 5.13 that E has to F a lesser ratio than E has to D. And again, E having to F a lesser ratio than E has to D, we can say by Proposition 5.10 that D must be less than F. And this is, again, what we wanted to prove. Given that A is less than C, we wanted to prove that D is less than F, and we have proven this. And we have shown in all three cases that if A be greater than, equal to, or less than C, D will likewise be greater than, equal to, or less than F, respectively. And this is what we set out to prove, which means we are done with the proposition, therefore, etc. QED. Now, I've got nothing to say about this proposition, so I'll end the video here and move on to 522.